Okay, if you want to graph the reciprocal of a quadratic or a cubic or quartic or beyond, there's a number of different ways of doing that. I'm going to show you one way that I think is a good picture of what's going on. So, as an example, the simplest example would be for f of x equal to 1 over x squared. Now this one's pretty straightforward. If you're to graph the function that's the denominator, so this is going to be y equals x squared. If you're to graph that, it just looks like this. So if you want to graph f of x, okay, label the axes, then you're looking at 1 over all the y values. Okay, so the points on this curve are x comma y, right? So what you're doing here is you're taking the y values of x squared and doing 1 over that to find out the new y values of this function. Okay, so 1 over 0, 0 is the y value here. 1 over 0, well, it's undefined. Can't have anything. 1 over a really small value of y here is going to be big. And 1 over big y values here are going to be small. So you end up with this, just like the 1 over x function, but the other side is a little bit different. Okay, so 1 over the y values here, well, they're all positive here. Okay, so you're going to get the same effect on this side, and it's going to look a little different than y equals 1 over x, but has some similarities. Okay, so that would be 1 over x squared, and the y-axis is a vertical asymptote. Now, if you had something that was like the same sort of idea, so another example here where f of x equals, say, 1 over x minus 2 squared. Well, this function, when you graph the denominator, y equals x minus 2 squared, would be just shifted over to the right 2 units. So there's 2, and it's just a parabola shifted to the right. So 1 over that is going to be this same shape here, but shifted to the right. You're going to have a vertical asymptote at 2 because you can't divide by 0. Okay, so you'd have at 2 here, you're going to have a vertical asymptote. X equals 2 is the equation of that asymptote. And then you'd have this effect here. Now, to get a little bit more complicated, if you had one where the bottom isn't necessarily a perfect square, you might have 2 zeros, so y equals, so f of x equals, let's say, 1 over x minus 2 and x plus 3. Well, if you want to graph that, well, you could graph the denominator first, so y equals x minus 2, x plus 3. Graphing that, okay, well, you'd have 2 zeros here at x equal to 2 and x equal to negative 3, and the parabola would look like that. It would have its vertex at, it would be at negative 1/2, right? So the vertex would be right here. Now, if you want to do 1 over this, well, now you're going to have 2 vertical asymptotes, because when x equals 2, well, you can't divide by 0, so that would be 0, and x equal to negative 3, you're going to have a vertical asymptote. So the graph of this function, okay, x, y, well, you're going to put negative 3 over here. So x equals negative 3 is an asymptote. and x equal to 2 is the other asymptote. And then on this side here of the asymptote, well, this part here looks a lot like this wing here. So at this point, 1 over really small numbers is going to be big. 1 over really big numbers is going to be small. So you have this effect again. And then on this side, you have the same thing. Okay, so it kind of looks like this part here. But now you have stuff going on in the middle. Okay, so that should be symmetric on both sides here. Now we've got to look at what's happening here. Well, these y values are all negative. 1 over a negative number is going to be negative. Okay. 1 over this y value here, well, you could find out what that y value is by plugging in negative 1/2 in here. 1 over that value is going to be the smallest. So at negative 1/2, you're going to have the peak of this piece. And then 1 over these really small negative numbers is going to be big negative on both sides here. So you'd end up having this effect, looking like a bit of an upside down parabola, but it doesn't go past those asymptotes. Okay, so that is for ones that look like this. Now, what if you had one that didn't factor? So the bottom, so it had no zeros. So say you have example here where f of x equals 1 over x squared plus 1. Well, x squared plus 1 has no zeros. There is no value of x that makes the denominator 0 in here. So you're not going to have any asymptotes, no vertical asymptotes. Okay, so let's take a look at what this graph looks like here. Well, so y equals x squared plus 1. Well, it's just x squared shifted up 1. So there's 1. And then it looks like that. Okay. So if that is our denominator, and we want to find 1 over those y values, well, then we're going to take the 1 here. Well, 1 over 1 is 1. So that's a point here, okay, because the y value here is 1, and you're doing 1 over that. And then as you go out here, you're doing 1 over bigger y values. So 1 over a bigger number gets smaller. So what happens here on both sides is you get this bell-shaped type thing. Okay. And that would be the graph of that, 1 over x squared plus 1. No vertical asymptotes. So those are the cases for the quadratic reciprocals. And very similarly, you can get cases for the cubic reciprocals. So let's do cubics here. F of x, let's say that equals 1 over x cubed. Well, 1 over x cubed will look a lot like 1 over x. Okay, so y equals x cubed is this. Okay. And so then y equals 1 over x cubed. Well, 1 over 0 can't do, so you have a vertical asymptote there. And then you're doing 1 over small y values here, big, and then 1 over big y values here, which is small. And then the same thing on this side, but only negative. So it looks a lot like 1 over x. And the thing is, this looks a lot like 1 over x to the 5th, 1 over x to the 7th, wherever that is, or sorry, x to the 5th and x to the 7th, wherever that is an odd power, it looks like this twist, maybe just a little bit tighter. So then 1 over x to any odd number is going to look similar to this. Okay, another example might be f of x equal to 1 over, let's do one completely factored with 3 factors, x minus 3, x minus 1, and x plus 2. Well, if you graphed this here, then you'd end up with 3 zeros. So at 3, at 1, and at negative 2. And when you graph that, it's going to look like this. Okay. Now, doing the reciprocal, 1 over that, so that's y equals the x minus 3, x minus 1, x plus 2. Now the reciprocal, this one, well, you're going to do similar process as before. And you're going to do 3 vertical asymptotes where it's 0. So at 3, 1, and negative 2. And then on this side, you're going to have this piece like this. Over here, you're going to have this piece like this. Okay, just like the x cubed graph on both sides. And then here, it's negative. This piece is all negative. 1 over negative numbers are negative. And so you're going to have a little upside down piece like this. And here, it's positive, so you're going to have an opening up piece like this. Okay, so you're doing 1 over positive numbers here, 1 over negative numbers here, and that's what your graph would look like. One more example for that. What if one of the bottom factors are squared? So if you had f of x equal to x minus 2 squared times x plus 3, say, well, you want to graph y equals, so that should be 1 over that. Okay, so 1 over that. So y equals x minus 2 squared times x plus 3. Well, that's simple enough. It touches at negative 3, or goes through at negative 3, and just touches at 2. So it comes down like this, touches, goes up, and then through. Okay. So then the reciprocal of that, well, it's going to have 2 vertical asymptotes here at 2. So x equals 2, and at x equals negative 3. On this side here, it's going to give us this picture. Over here, it's going to give us this picture. Okay. And then in here, it's all positive, so it's going to give us this loop going up. Like that. And you should be able to transfer this to the reciprocal of pretty much any polynomial function that's factorable or non-factorable.